Hi, this is Dan Burnett with All Things RTC and Varun Singh from CallStats.io, and we're here at the W3C TPAC meeting in California. This is where the WebRTC Standards Group meets. So we just spent 2 days doing that, just the last 2 days. And actually, it was I think it was a pretty good meeting.
It was an awesome meeting. We actually got a lot of stuff done. I think the major thing was the fact that we're close to candidate recommendation for both the WebRTC Pure connection and
Yeah,
the
actually,
stats.
right, yes, right. We officially at CR for the peer connection, first candidate recommendation. We may have to do another, but still, it's a big step that we've done.
And we think that in the next year or less, will be a proposed recommendation.
Yes, I think there's a very good chance of that.
And that's basically a big milestone for us because from now on in, like only major bug fixes, if I understood correctly,
That's right.
and a lot more effort on testing.
Yes, there are not supposed to be any major feature changes. It's supposed to be mainly clarifications. I'm sure we'll have some things we need to fix, again,
Right.
bug related, that may change normative behavior, but it's really only supposed to be that,
and that'll
not
come
feature changes.
and that'll mainly come from the implementation experience. So,
Yeah, that's exactly right.
so most of those changes would be welcome for the community.
Right.
And I think the other bit is that Google announced the kite testing platform,
Yes, right.
which is really cool. That means that we'll get a consistent output from all browsers and operating systems
Right.
to test against and see if the browsers are compliant to the WebRTC spec.
Right.
And I think there's going to be significant effort also put in for the WebRTC statistics, if I understood correctly, from the same folks at Kite. And just to add that we volunteered, CallStats has volunteered to do an analysis of support for the statistics that are reported by the APIs across platforms to make sure that the values that are reported are correct.
Right.
And that's going to happen as part of the run-up to proposed recommendation. So
Right.
I feel confident that we can get this done.
Yeah, and the Kite works really great. I actually interviewed Alex on Kite too, and so that's just some great work that's happening all the way around, really, to make things.
Yeah,
finish
so
up.
I think mad props to the community for coming together on getting this thing to the finishing. Oh well, not yet to the finishing point, but very close, and we can see it.
Yeah, we're finally getting more of the stability that people have been asking for, really, for WebRTC. So towards the end of the day yesterday, there was an interesting discussion about QUIC that it took some surprising turns. We were pretty amazed.
Right.
What happened?
I think so. Yesterday was or the second half of yesterday was mainly reserved for thinking about the next steps.
It's all the new stuff beyond 1.0.
Yeah. Right. So we agreed that we're not going to touch 1.0 anymore, meant that but brilliant ideas keep coming on. Right?
Sure.
And one of the things that the IETF has been working on over the last year or 18 months is about the QUIC transport. And I think Peter Thatcher from Google came up with a proposal to have QUIC as a transport for WebRTC, whatever we're going to call it. And the idea was that it would be at the same level as the data channel. Right? So either you could build a data channel on top of it, or and mainly about sending messages between browsers peer-to-peer using the QUIC transport.
I think that was the context that he gave was basically that you can use QUIC to build data channels, and interestingly, if you do that, you don't need a peer connection to do it. You sort of you have the transport piece. Yeah, right.
There is the ICE transport, and you could run QUIC transport on top of the ICE transport.
Right.
At least the initial proposal was not to merge it with the pure connection as yet. Right. If I understood correctly. Right. That's correct.
So before we go any further, could you briefly describe QUIC, maybe just a little bit about its history and why, the IETF, it is the big hot topic right now. So why is it that people are excited about it? What is it that it does?
Yeah, it's QUIC's, I think, the same energy that we saw with WebRTC 5 years ago. Right. Right. A lot more vendors and people interested. So QUIC is about getting connections over UDP between a client and a server. And was partly done by Google when they did the Speedy protocol. They said, oh, let's do Speedy. Speedy were basically, the genesis of the idea was to reduce page load times. Right? And they realized that
Reduce what load time?
the page load times.
Page load times, okay.
Right.
It was just, you lost your audio there. Yeah.
All right. And the page load time was an important measure to get it really low and like get all the pieces of the whole stack from the browser all the way down to the stack, like really working together.
Right.
And so part of the Speedy proposal became H2 or HTTP version 2,
Right.
but only the HTTP parts of it. And so QUIC came as a proposal way back in 2012 or 13 that Google is working on a new transport below HTTP2 to replace TCP.
Right.
And they wanted to do this over UDP. And one of the good things is that over the last 4 years, WebRTC has made so much progress that we can actually say that a lot of the UDP connections can actually go through. And in this case, it's server to client, or
Right.
client to server. So the success should be higher because you're not doing peer-to-peer as well. That's
Right.
so quickly about QUIC is the fact that it's HTTP2. Underneath it would be the QUIC protocol, which is basically just like trying to replace TCP. The beauty of the protocol is the fact that you can start a lot of streams. And basically you can start a connection and you say like I want to open a stream, you can open another stream. The idea is that if you have like hundreds of JPEGs, text and things like that, you can
Right.
structure that, you can open the streams, and if you scroll through the web page and like you realize that, oh, this picture has not yet loaded,
Right.
but the person's actually gone past it, you can actually go and reset it. Right, that's the thing. So
Okay.
so you can do
Okay.
better resource consumption. You can contextualize the HTTP part of your page in a
Right.
way where you would say like I'm requesting for these things. This just doesn't like the DOM objects actually not going to render this anymore. Don't need this data. Reset it.
Okay.
Gives you
Right.
more control. You get snappier web pages.
Okay.
Right, better user experience. I think so. That work started almost a year ago, and it's like moving really
It's moving really fast. Yeah.
right? Like people have multiple implementations. They did a bake-off at the last ITF.
Right.
I think they did an interim since then. There's the next ITF is in a week from now, I think. Yeah, at the end of this week.
Yeah. Right.
Right,
I fly to Singapore in just a couple of days and for ITF.
You should get around the world trip.
Yeah. Right.
So Peter basically went out and built the quick transport into Chrome, I think, and he ran some experiments on it. And I think what he showed was the fact that the data channels, that he could emulate a data channel with the quick transport as part of the work that he did
Right.
in current Chrome, right? So, and I think we were at the point in the day where we were saying, oh, this is cool. And we're talking
Right.
about, so this is something that we can do fairly quickly. And I think
Sure.
the group was behind the fact that like Peter should like basically go out and do this.
Right.
Some caveats,
Yeah,
but
right.
but then people started thinking about like what more could we do about it, right? And
Right. So I know that you and Peter and Colin Jennings from Cisco were all. You got really excited because you actually started thinking about other things you could do.
right,
And actually, before we get to that, one of the other things that I think is interesting about QUIC is, TCP and UDP don't necessarily play well together on the internet in terms of congestion. So maybe you could
Right.
just talk a little bit about that.
right. So
Because I think that's important for what's.
so over the
what you're about
last
to talk about.
25, 30 years, we built TCP, right?
Right.
And one of the things with TCP has always been fairness. Like whenever we come up with a new thing with TCP, like a new flavor, we always talk about how does it play well with the previous flavor of TCP.
Right.
And that's led us down like a murky path where we have a lot of like things happening with TCP, and people have monkey patched it and it's optimized. It works really well. There's new congestion control. I think there's the BBR, which Google announced earlier this year. But basically, the thing is with TCP is it's baked into the kernel. So since it's baked into the kernel, you cannot innovate fast enough. So if you come up with a new algorithm, you have to get it into a distribution. Like you basically go to a Linux maintainer and say like, hey, can you add it? takes a lot of effort to get it into as a default. So QUIC and BIC before it, they put in a lot of effort, and now they are the default like default TCP algorithms. But so if you want to deploy TCP at a faster rate, like you can't do it. So if there are fixes that you want to like do, there's 4G now, there's 5G coming. People like network topologies are changing. People are doing different things. Access rates are different. So you want to like keep adapting for all these scenarios, and that takes a significant amount of effort. And with UDP, there's always been the thing that if you just run UDP, it can either kill the TCP, and if you back off, like if you do not do proper congestion control on UDP, then it can either starve TCP or TCP can kill UDP.
Right.
So some of the effort that's going into as part of the QUIC is the congestion control algorithm, which will come for free now as soon as it will be part of the transport. Right? It's the same with data channels. As in you get
it almost sounds like a re-architecting of like the internet. I mean, doesn't this break the OSI model? It's almost like you took, you know how like you had UDP and TCP, and then you kind of add the secure version on top of that, and then you add, you know, flow control on top of DTLS, you know, for and so on, and now instead a lot of that stuff's getting moved down to the lower layer.
So like just going back to the OSI model, I think we know that it's been broken for a while, right? As in we had we had the HTTP model was HTTP, TCP, and everything below, right?
Yeah.
And so I think with QUIC we keep some of the HTTP parts. The TCP parts, which were now in the kernel, are actually now outside of it. They're in user land, gives more control to, let's say, a browser to like modify it. Also gives other people to like build on top of that. Right?
So I'm going to actually stop you for a sec. The term user land, could you just say briefly what that is? Most people probably know, but it's like the first time you encounter that, you're like, wow, what the heck is user land?
Like, so, yeah, so when you build an operating system, like all the things that are within the scope of the operating system is called the kernel land. And anything that runs on top of the operating system is called user land. So all our apps and everything that we build, like the browser, or is it all user land. And user land has only a very limited permissions in what it can do.
Right. It's just in today's internet world, the line I think shifts as to exactly what could be considered user land.
Right. Of course, the browser is in user land, but the apps that we write are on top of browsers quite often. So like on user land anyway now, and user land code. Some of the user land code is written by very smart people, so we can actually. We are at a point where we do not have to trust the kernel guys to do the right thing, but we can also trust a lot more other people to do the right thing in terms of development, and the browsers are like somewhat in that category.
Okay. So what was it that you, Peter, and Cullen thought was like so doable, so cool now?
Right. So
the conversation went through an interesting shift.
Right. Yeah. So I think so. Just to so Peter presented the fact that you could do data channels over QUIC, and it was not going to be part of the Peer connection. But then we were like, hey, we know QUIC goes over UDP, media goes over UDP, except QUIC's congestion controlled, and most of the video that we do is congestion controlled, but outside of the transport, right? So, but we can easily see of a way forward for us in terms of putting media, audio and video on top of QUIC. Right. And this idea is not very controversial because a couple of months ago, almost 6 months ago, Jörg and I, so Jörg is my PhD advisor, we came up with a proposal with Colin and Ronnie, Colin Perkins, and Ronnie even, on doing RTP over QUIC. Right? So we just went through a mental exercise of how we would do real-time transport protocol over QUIC. And I think the genesis of the idea is like we already have a UDP transport. It has security on it. It's like encrypted end to end, whatever that end is. We can RTP does a lot of things, and it's anyway due.
Due for rewrite.
And rewrites are difficult, right? RTP is a difficult protocol because it does not only like this real-time communication. Also does RTSP or real-time streaming. There's multicast, IPTV, your home, like Chromecast inside the house. There's so many things that use RTP in different topologies and scenarios that like changing it is not easy because invariably it will break something.
and then feedback stuff's been added. There are all kinds of things that have been layered
Right,
on top.
right. So
Error correction.
right. So there's a lot of things. Although we do know that RTP was built in the early 90s. So, and
Right.
we're in 2017 today. It's 25, 30. Like
Right.
it's
been a while.
about time that we re-envisioned it and at least said like, okay, let's build a better protocol for something that's more relevant today, right?
Right.
And so with QUIC, so we went through this exercise and we said like, we, to do RTP over QUIC, there are several things that we could do, like video. And since we went through that mental exercise already a few months ago, when Peter said that he had, running code at this point in time that could already do data channels, we could see, at least I could see, and I think that's what Cullen and Peter could also envision running audio video. And even though he thought it would be controversial, if there are two independent people in the room who think that this is possible,
Right.
it makes it really interesting for everyone else because at least we jumped on the opportunity of having this possibility explored.
Right, and
in a
the
deeper-
three of you actually have pretty good understanding and history and background here. So this is not like, oh, that would be kind of a neat idea. No, you think, oh, this could really work.
Right, as in,
So it's worth discussing.
right, and the other reason why we are really interested in QUIC, independent of our RTP, and this is that our own service call stats runs on H2 already, so HTTP2, and we've
Right.
been following QUIC very, very closely. We also support gRPC, but so for us it would be, from a scale point of view, like an interesting exercise to see like if QUIC would bring us a lot of like savings in terms of resources, both on the infrastructure side and also to maintain it. So we've been looking at it from a client-server perspective, so
Right.
it becomes easier for us to also think about it since we are a real-time company, communications company, like extending whatever, like both these things, merging it makes it easier for us as a company as well because people can easily, engineers working on the server side can also understand what is happening on the client side between peer-to-peer connections.
Right, meaning client to client. That's
Right.
the thing that's, one of the things that's so new about WebRTC. It's
Right.
not the traditional client-server model. It is client to client.
Right.
And you're saying it applies there as well.
Right, and then it becomes easier for engineers across who do not currently talk to each other about the technical challenges to actually have a conversation. So for us, I see this as a big step forward.
Sure, sure. Now the conversation didn't actually end there. It actually went on to talk about ICE.
Right.
Even.
Yeah. So you want to talk about
No, I don't want to
Project
talk
Snowflake?
Yeah, go ahead. Well, go ahead. I think.
Right.
Yeah.
So so like we've been working with ICE as a community for a long time, and like
Wait, we who?
like the browsers, the
whole web-
vendors,
yes,
the whole
right,
web community, including the IETF and the web, right?
Sure.
So this is something that we share in common today.
Right.
And I think when we started WebRTC, we wanted to shield some of the pain of setting up connections between browsers away from the developer.
Yeah.
But and over the years, we've seen like while we've tried to do this well, there's still the complexity of implementing this has been borne by the browser vendors and the people who've been maintaining their RTC stack. So they had to, like, it's not just the browsers, but also the SFUs, the MCUs, everyone else who wanted to play inside the WebRTC ecosystem had to implement this. So it's not just like 4 or 5 teams around the world, like the browser teams, but a bunch of people.
Right.
And what we've seen, like everyone has a different understanding on how to optimize this going forward. So first we agreed on something and we implemented it. I'm sure that you can get people onto a different call where you can just discuss the scars of implementing ICE. Right? And but
it was a hassle, but it definitely has provided. It's dealt with a lot of the problems that you have with NATs, firewalls, private clouds, etc.
Right.
That are they're just horrible for applications, and it made sense to try to solve that problem once, essentially, in a more intelligent way.
We've written blog posts and we've done the WebRTC metrics report ourselves, and we've shown that like connection failures have gone down like over time. So we're at a point where the connection failures are down. Like we need to put somewhat more infrastructure to get around some of the firewalls and NATs, and people as an industry, like there are turn servers, there are open source turn servers, services running as a turn, which are helping developers get their product out quicker, faster, reliable, more reliable, right? And so related to ICE, one of the things that we've seen at CallStats, and I can only speak to what we've seen, is that sometimes the connection that got set up is not exactly the one that would be the best for the endpoint, right? And
Okay,
best
right.
can mean different things. So, like
Sure.
for example, you have a home connection, you have your Wi-Fi and 3G,
Right.
but your 3G might be the default one,
Right.
but maybe you're a bit far away from your Wi-Fi terminal, and the signal strength is low, and the connection's set up, and maybe this is a local condition. So like ICE could figure that out and say, yeah, my signal strength's lower, so maybe unless it improves, I'm not going to use this one.
So ICE will guarantee you a peer-to-peer connection if one is available, but that doesn't mean it'll guarantee you a good one.
Right, and there are a lot of people working on like what good means, right?
Sure.
So I think one of the discussions that came about even before we went into that meeting was me expressing interest to explore a way where a third-party cloud system or the first-party cloud system, like in our case, third-party,
Right.
that call stats could tell their endpoints, like people that are integrated, like which route to use, right?
Okay.
And but today the API is a bit complex to do that, and it's not easy. You would have to do filtering, and
Sure.
like someone needs to give up control, and sometimes you want to capture all of them, make sure that you get one or more connectivity, because if the worst one is the only one,
Right.
you do not want to pre-filter it.
Yeah,
You want,
right.
like once you have connectivity established over several of them, then you want to say like, oh, pick this one out of this set.
Right. Without
Right.
sort of losing what you have as your backup.
Right.
effectively.
Right. So and building something like this is, I wouldn't say challenging. As a third party, of course, it's challenging, but like as a first party, a lot of people need to do this
Right.
themselves and learn about doing it. But they don't have enough control, so some of it is like doable, but not really like sane.
Yes. Right.
And so I
Well,
think
a lot of this stuff is esoteric, and it's buried in the protocol stacks, right?
Yeah.
So even putting a hook in is not necessarily easy, and then explaining to somebody what that hook means and how to use it is really tricky.
Right,
sometimes.
and a lot of times it's like, do what I mean and not what I say, right? And I
Yeah.
think that's a lot of places this is a challenge, right?
Right.
So I think Cullen's proposal was like scary ice or something like that.
Right.
So he made a proposal where he said like, why don't the endpoints themselves, like once they gather, decide how to like which candidates they want to check over, and like send the connectivity checks by hand from the JavaScript. And once a connection, like once an acknowledgement or a response is received for this done request, then they would get an event. The app would know, yeah, I got a request on the far side, and the local side will also know, like, hey, the other side acted, right?
Right.
And this basically moves a lot of the complexity out of the browser into the hands of the JavaScript.
Right. So basically, there are only a few there are a few functions that the browser handles, but the rest of what we know of as ICE today is just a JavaScript application.
Right. So like a lot of the state management and like what you want to do next, how do you want to pace your stun requests are not part of the browser anymore.
Okay,
And
right.
so JavaScript can actually control this, can actually say, oh, I'm on a 3G endpoint, and I want to like actually send my stun checks less often or more often. Like they can make that
Sure.
distinction just based on, not based on the browser making that decision for them, but
Based on their application needs or environment that they
Right.
know about or whatever.
Right, and this
Sure.
became like a part of the discussion, which was something that we were interested in as well. It moved the envelope further.
Right.
So like we got a lot, we believe that as a community we will get a lot more control over the API and
Right.
over the transaction of
Right.
connectivity and control over that.
But it's not just the control. I mean, shouldn't it help with testing as well and sort of
Oh, yeah.
the complexity of those pieces?
Right. So, assuming like 5 to 6 people at each of these browsers, I don't know the exact number, but
Sure.
put in the effort to build all this, it means that like they took on the responsibility of testing it, making sure it worked. But we know from first-hand and second-hand experiences that they're still working really hard on like the corner cases,
Right.
right? And corner
Right.
cases are sometimes really hard to like envision, but it becomes easier for developers to do this, right?
Right.
To maintain this as a community, like instead of
Sure.
5 people at each of the browsers, like the same 5 like people from those 4 browsers or 6 browsers and 5 other like infrastructure vendors, you have a pool of like 50 people now, which can actually like maintain a JavaScript version of ICE or whatever you want to call it.
Sure.
And so I think we went through some naming exercises yesterday. Do you want to talk about?
Yeah. So, well, we were just trying to think about, sort of the ICE theme. And for those of you who know the IETF, people in the IETF really have fun trying to come up with acronyms or names that are they could be considered clever. Put it that way, right? And so, so we were thinking this is kind of a light version of it, and so I suggested, ICE chip, and then you suggested.
So, like we've had
something
ice
else.
for a long time, and I was wondering how we could incorporate snow in it. And so when you said ice chip, I was like, yeah, snow, and snow like, and I said snowflake, and people loved it immediately. I think.
Yeah, that it definitely stuck, right? That term. So people started calling this Project Snowflake. Now, project as in, a few people in a room were discussing it, at W3C, but still, it's interesting where this could go.
Yeah, and the beauty of it is like 2 people independently thinking of the same problem, coming together at an event serendipitously.
Serendipitously.
Yeah,
Yes.
I can use that. And basically converging on a solution, right?
Yes.
Or a starting of a solution.
Or a direction for it, right.
And with more people, I think we can get this off the ground. So I think it's now going to come back to how much energy the community has.
Sure.
Like 2 people are never enough to like take this forward.
Right.
We'll of course get the ball rolling, but more people will need to like either say this is something that they would like as well to see happen.
Right.
So there are people like you who are listening in would be like your opinions would be really useful for us.
Right.
As people who are building the next version of, and also like as input, as in coming and doing the work as well. Right?
So actually, along those lines, why does this matter, right? So in the end, it's like, this was a fun discussion, and it felt like a detour, but an important one that could have long-term implications. So, WebRTC is, fine, right? Why do you need this? What does this really do for you, building all these pieces on top of QUIC?
So WebRTC was actually very important when it came about, because at the time there were maybe like 10, 20, 30 apps, there were like different platforms, Adobe and so on and so forth, which had like ways of doing communication. But they had their own ways of doing it. So WebRTC was really important. And I think one of the biggest things that we achieved with WebRTC is a suite of protocols that we all agree as an industry.
Right.
Like not only the protocol, sometimes even like the flavor of it, right? Because people
you're talking about the stuff, the plumbing.
Yeah,
pieces,
the whole plumbing, right?
Not even the JavaScript.
No, JavaScript was like just like was a cherry on the top. Now we have like APIs that we can use. But when we say like when we talk about H.264, we're like there's so many profiles of like that codec. We agreed on which one we want to do, right? Which one would be supported by all the browsers.
Right.
The same thing with HTTP. There are like so many variants of HTTP. We said, oh, we can do some variants of it, and like here are the options that we like, and here are the options that we do not like. These are the options that we should be exploring, right?
And some of the enhancements were things that actually people have been wanting to do for a long time. Bundle, the notion of bundle,
right?
And routing, sending all this traffic essentially over a small number, right? Small number rather than having to.
Right. So if you look at the whole 6, like all the layers that we call the OSI, and if you think about, we standardize everything, right? We standardize like what are the DSCP code points how are we going to mark the packets? Right. Like there are so many ways of marking the packets. We agreed on a few set of classes that we could use for real-time traffic. So we agreed on that. We agreed on how V4, V6, how would we traverse the NATs and the firewalls? Right. How would we prioritize these candidates? And if you go up the stack, you can you can see like what profiles of RTP we are supporting, what header extensions, what are receiver reports or extension
Right.
reports you're supporting. And if you go like further up, like in terms of security profiles, like we support DTLS, and this basically before meant like you had 4 options at each level. Now we have 1 of them. Like we basically know as an industry, like if you want to do real-time communication, what exact things
This is what you do.
Yeah, and
Right.
so we converged on something, and now I think what we're looking for, and I think this is alluding to your point, like why was it interesting? Is
Right,
because
exactly.
now we are at a point where we've agreed on the first principles. So now we can start building on top of these first principles, sometimes relaxing what we already agreed on the first principle. So like the ICE is like a very good example of where we all know what the first principle is, want to relax the way we want to, like we do not want to coordinate this
Right.
across all endpoints at all the time, like
Right.
want to give the JavaScript or the application developer some more control. Also means that we also over the years have realized that JavaScript developers are really awesome and can understand some of the complexity.
Right.
And when they don't understand some complexity, there's some smart guy who will come out and write a JavaScript library which other people depend on.
Right.
And that complexity is then like a community effort.
Sure, sure. And you know, I know some of the things that you were discussing as possibilities, I mean, it just wasn't possible before to do this, right?
Right.
It's not until you had this highly optimized QUIC, really, that looked at round trip times and things like that. I mean, just everything together is really
Right.
designed to be
Right,
heavily
and
optimized.
just going back to QUIC, as in QUIC's also come out from a lot of effort over the last 4 or 5 years. Google's been running it on the back end of YouTube, delivering videos over QUIC for a while, so they kind of
Right.
know how much success rate that connection between a client and server was. The WebRTC came up with their numbers of connectivity.
Right.
They're now quite similar, like they're 95+% connections on YouTube, and it falls over to TCP whenever it cannot get through. So
Right.
the user actually does not feel frustrated.
Right.
I think we would have to think about similar lines, similar things along those lines for WebRTC as well if you want to do this.
Right.
But since QUIC I think the major landmark is QUIC is congestion control transport for UDP. The assessment of how well it would work with UDP for real-time traffic is yet to be determined. But the fact that it is in user land means that we can easily change it or maybe control the type of congestion control.
Right. And innovate in that space.
Right, and that can be
Right.
led to the people, led by the people who understand congestion control, understand real-time traffic,
Right.
to do that. And for us who are working on the using of the transport, we can like if that problem is handled by them, we can build like more interesting apps by actually getting the raw video frames or the encoded video frames directly into JavaScript, and then having control over when to send those frames out, and then playing them back on the other side. So that would mean JavaScript would be doing everything that a native application is capable of.
Yeah,
in terms of control.
That's pretty cool.
Right.
That's pretty cool. So, you know, I'm tempted. I don't know whether to ask you this question or make the statement. Okay, and I think it might be easy for someone to be worried that wait a sec, they're talking about something completely different. This sounds like whole new JavaScript APIs. I mean, is WebRTC being thrown away? WebRTC 1.0?
No.
And no, right? This is all in future functionality. So how is this likely to look? I mean, what do you think? You know, are we going to see perhaps the next version of WebRTC has just maybe some more hooks, or maybe it actually goes further and it defines some of these other kinds of APIs? I mean, I'm asking you to speculate, and
yeah.
who knows?
I think my speculation, and I think now that we have the 1.0 working, I don't think we are going to break backwards compatibility ever. I think what we're going to do perhaps is figure out a way, if we want to do this, that would be under the layers. Like the browser would still expose all the old functionality, and then like the JavaScript would expose more of these functionalities, and people will experiment with it, and then there would be at some point where we would feel confident enough that like some of these things can be brought back into the 1.0 kind of API, or so that the 1.0 would use the same APIs internally to Like you would shim
Right.
them in some way that that you would call the new API as part of the one API.
Right. So it's not like your application, you just, oh no, you have to rewrite your whole application now. Not at all, in fact.
I would hope not. As in,
Yeah, right.
like we put in a lot of effort in doing this. It would be really bad if people came out and say like use this new shiny thing, and it actually like the old shiny
Yeah.
thing is not shiny enough. Right?
Well, and in fact, it's nowhere near done, right? I mean, so this is an idea that was discussed yesterday,
Right.
and it's going to take a while, right?
Right, and if you look at some of the like scary proposals, they were small bite pieces on improving certain aspects. It was not a complete new proposal of like,
Right.
oh, we actually have to change everything. It was like, oh, we want to optimize just how we do connectivity or control over connectivity. And then the second bit was like, how do we like actually send video over QUIC? And that would like in most cases, the pure connection, you don't even have that control today. You just create a sender, create a track, create a sender, create a transport, wires up by itself, and you basically associate tracks to senders, and that's it, right?
Right.
Like everything, and I think what is being proposed here could easily work with that mental model, because you are just changing small bits, optimizing them along the pipeline that people still don't have control over.
And just like any new thing, this is likely to take, some years probably to get worked out.
I would say a fair amount of time, but
okay, maybe not as much time as like WebRTC has taken to get to this point.
Like I think a fair amount of time. If the QUIC transport's already there, we have like the first moving part.
Right.
Even
QUIC
before
isn't done. Right, in IETF.
Right. So there's that bit as well. There's features in QUIC that would be requested by the community doing real-time communication over QUIC. There will be some flavors of features that are needed that are not currently available.
Right.
We would need to revisit the idea of do we want to do RTP, or do we take this as an opportunity to reassess that? Like we could do a better format. Better.
Right. It doesn't have to be RTP. It can be media, in whatever media means today.
Yeah, and a new container. That container can be RTP, or it could be like RTP Lite. There's still things that RTP did well, like it does timestamp its stuff. It says like all these group of packets belong to each other, which may not be needed here because you could open streams for each frame. So some of those things will necessarily not be needed. But there are timestamps and packet sequence numbers, frame sequence numbers. So they're like things that RTP did right, which we would want to like borrow in this. So I think it's an exciting moment for us. It's just been day one. So I think we'll need to follow up more on the progress as we move forward.
Yeah, I think it's unlikely that this was a waste of time. I think there was something that was realized that's important and will probably result in
and the fact
some
that
good new work.
And the fact that there were a lot more people interested in the proposals. People did not think that they were entirely bizarre.
Yes, often someone proposes something and it's like 4 people go, that's ridiculous, it'll never work. Know? And that's not what happened, which is quite interesting.
But I think it even solved some of the things that I wanted in version 1, or like something like some more control, which was always like, when you want a little bit more control, it's always a trade-off, like how much control.
Sure.
With these new features, we might actually get a lot more control. And I think that's what we'll have to assess as a community. Like how much control is good, like what exactly are we giving access to in JavaScript.
Right, and it's not just control, it's control in a hopefully cleaner manner.
Right. Where you do not have to guess what the browser may have been doing. Because a lot of the times today is, the browser's, I think, doing this, so let's write my code in a certain way because of that.
Right. So for people who are interested in this, it's too early to say exactly where work is going to happen, but what do you think if someone, watching and listening says, actually some of this sounds interesting and I want to pay attention to where it's going. Where is work likely to happen, do you think, that they should perhaps pay attention to?
I think the W3C mailing list for WebRTC, I think this is where it's going to happen.
So it's not IETF?
I'll hold my thought on that.
I know. Well, it's interesting. That was a leading question, obviously, but I did hear some interesting comments during that discussion, that there might not be as much work needed in the IETF as one would think in order to do this.
Right.
And that's really cool, actually, because the more we can do in the userland JavaScript space, the better.
Right. So I think
Right.
one of the things that's taken us so long with WebRTC
Right.
was the fact that we used SDP, which was
Sure.
like because we had a lot of experience with that, right? And
Right. There was a lot that was spec'd already.
Right.
And there was a lot of experience.
Yeah, and I think figuring out how or what we actually wanted, because there were so many ways that
Right.
one could express a certain thing,
Right.
meant so we got this really complex language where we could express a lot of thoughts, but then we had to nail down like what we really wanted for WebRTC 1. So I think we've learned a lot in this process because we saw what the enrichment of like a lot of features would be, and
Right.
what are the exact features we want. So we drill down to something that we understand very well. I think one of the biggest reasons for ORTC and like the NV work was to like decouple ourselves from the SDP model.
Yes.
And I think that would still happen. And because of that, I think I believe some of the IETF work that we've been doing would go away, right?
Okay.
But
Right.
of course, like if you're going to send a packet on the network that needs to follow a certain structure that other things on the network can observe it and like play nicely with, that work would still have to happen with it.
Sure.
So like if some part of the project Snowflake would be like a simpler ICE or like oh actually this is all we need or the mechanism, that would have to still happen in IETF.
Okay.
And I think that's the important bit.
Okay. Well, cool. It's very exciting.
It was.
It'll be fun to see where this goes.
Yeah, and thank you for taking the opportunity to like call me on, and it's always nice to speak to the community through this platform, all things RTC. So really good and good turnaround time, right? So
Yeah.
we did this discussion yesterday, and
We're already we're talking about it today, and hopefully have it up very, very soon. I'm not
Cool.
going to say a date because that always gets you in trouble,
Cool.
but very, very soon.
It was a pleasure, Dan.
Likewise, thanks, and we'll talk again.
Yeah, thank you.
All right, bye.
Bye-bye.